So this is going to be the solution set for adding and subtracting rational expressions with factored denominators. So we need to find the least common multiple of these two trinomials. The least common multiple is always the product of the two divided by their greatest common factor. So we need to determine what their greatest common factor is. To do that, we need to work with them one at a time and completely factor them. With our first, we have a common factor of 13. So this can factor as 13 times k plus 1 squared. For the second, we notice that there's a common factor of 5k cubed. When we pull that out, we have k squared plus 5k plus 4. So that's 5k cubed times k plus 1 times k plus 4. So the least common multiple, I don't know why I wrote 15 when I said 5. The least common multiple will be what you get when you multiply these two together and divide by their greatest common factor. The only common factor they have aside from 1 is a single factor of k plus 1. So the least common multiple will be 13 times 5, or 65, k cubed, k plus 1 squared, k plus 4. So this is, as far as we can take it, this is our least common multiple. So we're careful to check as we're transcribing it through. And then we move on to our next one. Subtract the following rational expressions. So here the denominators are factored, and we have a single factor in common. So our first term, we're just going to have to multiply by 6k plus 5 over 6k plus 5. Our second term, we're just going to need to introduce that 7k plus 2 over 7k plus 2. So we'll start by moving it to our workspace. Now that we have it transcribed to our workspace, oh, that was a negative 4. The first thing I'm going to do is recognize subtracting a negative is adding a positive and change both of those signs to plus signs. From there, our denominator is going to have the 11k minus 1, the 7k plus 2, and the 6k plus 5. To get those same results in the numerator, we're going to have a 6k plus 5 here, and a 4k times a 7k plus 2 here. So those were the factors missing from those respective denominators. So now we do have to simplify. We're allowed to leave things in the factored forms, but simplification means we can't leave our numerator like this. So we have to multiply it out and figure out what it becomes. We'll have a single term with k cubed. It's an 18k cubed from the first term. We'll have a 15k squared from here and a 28k squared from there, for a total of 43k squared. We have now accounted for everything but this term, which is a simple 8k. So this is our simplified expression that we will now submit as our response. And once recorded, we can double check that we have everything transcribed correctly from our workspace and submit. So this is another instance where we have to add up two rational expressions with factored denominators where they do have one factor in common in the denominator. Once transcribed, we put it over a common denominator of 5m minus 8, 3m plus 7, m minus 4. Our first term was lacking the 3m plus 7, and our second term was lacking the 5m minus 8. So this is our first step in the simplification. And now we are going to multiply through. We will have the 5m minus 8, 3m plus 7, and m minus 4 terms here. Now as we're multiplying, we're only going to have one m squared term. That's probably 7m times 3m. We're going to have a 49m here and a 50m here, which gives us a 99m linear term. And our only constant comes from the second multiplication. That's a minus 80, which we copy over, double check for accuracy, and submit. Now our final question is another least common multiple, which again is the product of the two divided by their greatest common factor. So we need to start by completely factoring each of these two expressions and taking a look at what remains. We'll start by completely factoring the expression on the left. So after transcribing it exactly as is, we note that there's a common factor of 3z, leaving us with z squared minus 2z minus 3, which can be factored one step further as z plus 1 times z minus 3. So this is the fully factored form of the expression on the left. We now continue with the expression on the right, noting that we have a 7z squared common factor, which gives us a z squared plus 3z plus 2, which we can factor further as z plus 1 times z plus 2. So again, we have some common factors. We have a common factor of z to exponent 1 and a common factor of z plus 1. So that makes our greatest common factor 21z squared, or sorry, not greatest common factor, least common multiple is 21z squared times z plus 1, z plus 2, z minus 3. We carefully transcribe that as 21z squared times z plus 1, z plus 2, z minus 3, and submit. This concludes the solution set for assignment 1.05, number 3.